Application of derivatives. We have 6.1 and 6.4 exercises, and the topics are deleted. So we have now increasing function. First, we will see what is increasing function. Increasing function. Increasing function, if you want to understand this increasing function by the graph, so this is x-axis, this is y-axis, okay. Increasing means if it is continuously increasing, then suppose it is increasing, so this will be going like this, okay. But here they have not said strictly increasing. If it is said strictly increasing means the graph will be that one. But here it is increasing means at some point it can not be increasing, means if it will come like this and at this point it will stop increasing and it will go like this or like this. So this means you can see that type of turn you can see, or corners. If these two corners A and B at these 2 points A and B, it is not increasing, it stops for some time, okay. So that's why it is not exactly increasing at every point. So if we take, suppose this is the point x1, this is x1, and anywhere you can take greater than this x2 on x-axis. If we take 2 points on x-axis and x-axis, this is x-axis and this is your y-axis. So what is the value of the function? This function will have the value. Actually, we are representing the value of the function at this point on y-axis, and this is what? This is f(x1), the value of the function at x1. This is represented at y-axis. Similarly, at this point, the value of the function is f(x2). f(x1), f(x2). So here you can see x1 is less than x2 and fx1 is also less than x2. It can be equal for some point if x1 and x2 both will come at a point, or somewhere you can find the same values. For increasing function, you can have the same value. So that's why a function is called increasing in this interval I. This is the interval x1 and x2 is the interval. In this interval, we have to consider whether it is increasing or decreasing. So the definition is a function is said to be increasing in this interval, to be increasing. We are writing increasing. There is another definition will come, strictly increasing. So it is increasing function, said to be increasing function, where in this interval and in any interval, in interval I, some interval, if we take some point on x-axis in that interval. Suppose we are considering this interval I, okay. So in this one we will take 2 points, so that x1 is less than x2. We are taking x1, so value of x1 will be less than value of x2. Two different points, two distinct points, implies that value of fx1 will be less than or equal to fx2. Okay, so at 2 points it can be equal also for all x1, x2, for all values that we are taking inside the interval. x1 and x2 belongs to the interval I. Okay, then it is called increasing function. But if it is strictly increasing, then the difference is only this less than equal to will not come. For a strictly increasing function, if we have to prove that a function is strictly increasing function, strictly increasing function. This is increasing function. This is what? Increasing function. For a strictly increasing function, as I told you, strictly increasing function, the function is increasing everywhere. It's like this, you can say that it will go like this. It is increasing, no? Continuously increasing. Should not go side. It should increase. Should go on increasing like this. Then this sign will change. This will not be fx1 will not be equal to fx2. The same definition, a function is said to be strictly increasing. Strictly increasing if and only if in the interval I, if x1 is less than equal to x2 implies that fx1 is also less than equal to fx2 for all x1, x2. This is the symbol for all x1 and x2 means points we are taking inside the interval, obviously. x1, x2 belongs to interval. So this is increasing. The same thing will be applied for decreasing function. If it is decreasing function, similarly, there are two types of decreasing functions. Decreasing function, which is not strictly decreasing, it can have the graph like this. Decreasing function will have the graph like this. Is decreasing like this. No? So similarly, the same definition, only a function f, a function is said to be decreasing in the interval if x1 is less than equal to x2, implies that f x1 is greater than equal to f x2, because x1 you are taking x1 here and x2 somewhere here, because x1 is less than, so you can see this is fx1 is greater and fx2 is less. This is fx1. The value of fx1 will be greater than the value of fx2. This case. So opposite, this sign will be inverted. And for all x1, x2 belongs to the interval. x1, 2 belongs to the interval. Okay. Similarly, if it is strictly decreasing, then this sign will be greater than equal to only, not greater than equal to, only greater than. So strictly decreasing function. So in order to show that it is strictly increasing, decreasing, this condition should be followed. So we will prove by using this condition. So a function, short form of function is said to be strictly decreasing in the interval I if x1 is less than equal to x2 implies that fx1 is greater than equal to fx2 for all x1 x2 belongs to I, and its graph will be like this. Decreasing means it will go like this. Decreasing. Okay. And decreasing function at a point. So at any point we have to show that we can see at that point 2 points will be considered, and we can prove that whether it is increasing or decreasing. So for example, example number 1 we are taking to understand better.